Welcome to Two Projects. In this video, we are going to explain the project Fruits and Vegetables Classification using Machine and Deep Learning. Before diving into the execution, let me give you an overview of the project. Imagine you're at a grocery store and you want to buy some fruits and vegetables. How do you know if they are really fresh? Usually, a person checks them one by one looking for signs of spoilage like discoloration. But this process takes a lot of time and sometimes mistakes can happen. So this is the traditional method, that is manual inspection, which is time consuming, subjective and prone to errors. So we are working on this project to make this process easier and more reliable. Instead of relying on people to inspect each fruit and vegetable, we are teaching the machine learning and deep learning algorithms to look at pictures of fruits and vegetables and tell us if they are fresh or not. So they recognize patterns in the pictures. For example, it might learn that fresh fruits usually have bright colors and smooth skin, while stale ones might be discolored or have spots. So they'll learn these type of patterns and they'll recognize fresh and stale fruits and vegetables. So by doing this, we are making the whole process faster and more accurate. Farmers can use this technology to quickly check their produce for quality. Food processing companies can use this to sort fruits and vegetables more efficiently. And in the end, it means you can trust that the fruits and vegetables you buy are really fresh. So now we will look at the workflow. So in our dataset, we have a collection of images showing various fruits and vegetables of both fresh and stale conditions. Before we train our machine learning and deep learning models to understand these images, we need to prepare them properly. That means we have to perform some pre processing steps. So we use two libraries, OpenCV and Pillow, to perform image processing tasks. So these tasks involve adjusting the images sizes, that is resizing, ensuring a consistent background across all images, and converting them into a format that our models can understand called tensors. Once the images are pre-processed, we employ a technique called data augmentation to enhance our dataset. So data augmentation involves creating modified versions of our original images to provide our models with more diverse examples to learn from. For example, we may apply transformations like shear transformation, zooming, horizontal flip, reshaping, etc. So we use image data generator to enhance the dataset. So by augmenting our dataset, we effectively increase its size and diversity, which helps our models generalize better and perform more accurately when classifying fresh and stale fruits and vegetables. So this process ensures that our models can recognize various characteristics of fresh and stale produce under different conditions, making them more robust and reliable in real world scenarios. So once this pre-processing is done, we split our dataset into training and testing sets for model building and evaluation. On train set, we'll train our models, and on test set, we'll evaluate our models. And we will employ various machine learning and deep learning models like KNN, XGBoost, CNN, Exception, etc. Each model learns differently. After that, we'll test all these models and will select the best performing one among them for vegetables and fruits classification, the fresh and stale ones classification. So this is what happens in this project. So this project benefits farmers, food processing industries, retailers, and consumers alike. Farmers can utilize the technology for efficient quality assessment and sorting of produce, optimizing their harvests. Industries and retailers can ensure product quality and minimize waste by employing the system to select only the freshest fruits and vegetables for distribution. Ultimately, consumers enjoy improved quality assurance and fresher produce, enhancing their overall experience and satisfaction with the food they purchase. So, this is the overview. Now, we'll see the software and hardware requirements to execute this project. So, hardware requirements are operating system of Windows, processor of i5 and above, RAM of 8 GB and above, and hard disk of 25 GB and above. Software requirements are application needed is Anaconda, primary language required is Python, front-end framework needed is Flask, backend framework needed is Jupyter Notebook, database required is SQLite 3, and front-end technologies required are HTML, CSS, JavaScript, and Bootstrap 4. Now we'll understand about the algorithms built. So these are the algorithms proposed by the author in the base paper, KNN, XGBoost, CNN, and Exception. For improved performance, we are proposing voting classifier and a hybrid model in this project. We will be building all these models, the models proposed by the author and the models we are proposing, and we'll compare their performance using different performance metrics like accuracy, precision, recall, and F1 score, and we'll select the best performing one among all. So now we'll understand about the algorithms which we have proposed. The first one is voting classifier. So the voting classifier blends the predictions of multiple models, decision trees, and XGBoost in this project to make a unified classification decision. Each model offers its prediction based on the input data, and the voting classifier aggregates these predictions to form a final decision, often resulting in improved accuracy and robustness. Combining decision trees known for their simplicity with XGBoost renowned for its effectiveness in handling complex data relationships enhances the classification system's ability to accurately differentiate between fresh and stale fruits and vegetables in this project. The next algorithm which we have proposed is a hybrid model. So the hybrid model merging exception and CNN, that is convolutional neural network, combines the feature extraction capabilities of exception with the pattern recognition strengths of CNN. By first leveraging exception to extract detailed features from images and then refining them through CNN, this hybrid approach enhances classification accuracy. This fusion is apt for our project as it maximizes the efficiency of a feature extraction while enhancing the model's ability to discern subtle differences between fresh and stale fruits and vegetables, ultimately ensuring accurate quality assessment. So, this is about the models. So, after comparing all these models' performance, we have observed that hybrid model has outperformed all other models in all the performance metrics. So we have deployed hybrid model into Flask web application. So we will be executing the project using Flask web application. So before execution, first we need to open the code folder which contains the project source code files. So this is the code folder and these are the contents I have in the code folder. In archive folder, I have required data set. So we can see this folder contains 12 subfolders. So these are different classes in the data set. So each folder represents a class such as fresh apple, fresh banana, stale capsicum, stale orange, etc. So each subfolder contains images depicting respective fruits or vegetables categorized based on freshness. So these are all fresh fruits and vegetable folders. These are all stale fruits and vegetable folders. I have respective images in these folders. So in fresh apple folder, I have fresh apple images. In fresh banana folder, I have fresh banana images. In fresh tomato folder, I have fresh tomato images. In stale orange folder, I have stale orange images. In stale banana folder, I have stale banana images. In the same way, I have respective images in other folders also. So on these images, we will train the machine learning and deep learning models. So before training the models, we will split these images, all the images from all these folders into two subsets, train and test sets, in the ratio of 80:20. So train set is for training the models and validation set is for evaluating the model's performance on unseen data. So after doing this, after splitting the dataset into train and validation sets, we have stored these two sets in output folder here. So we can see I have train and validation folders here in which I have train and validation sets. So now 80% of the images from these folders are into train set and 20% of the images from these folders are into validation set. So we will train the models on train set on the images from train folder and will evaluate the model's performance on validation set, that is from the images in validation folder. So this is about the data set, and this is sample folder in which I have images again. On these images, we will make the classifications. This is static folder. This folder consists of files related to CSS, JavaScript, and Bootstrap. This is templates folder. This folder contains all the HTML pages used in the project. It typically includes files like index.html, about.html, etc., which represent different pages of the website. This is app.py file. This .py file contains the information related to front-end logic. It includes code written in Python that handles server-side operations such as processing user requests, interacting with the database, and generating dynamic content to be rendered in the HTML templates. And these are model files which contain algorithm information. These files will be loaded into the project code during runtime to utilize the trained models. This is Notebook Jupyter source file which contains a combination of code, graphs, and outputs all in one place. So Jupyter Notebook allows users to write and execute code in individual cells, making it a popular choice for data science. And this is signup.db file. This file is the database file used to store user information. It stores data like sign up details of the users. So this is about the code folder. Now copy the path of the code folder from the address bar of the file explorer. I'm copying it. Open Anaconda prompt. Use the command cd followed by a space and paste the copied path and hit the enter button. So this command is used to change the current directory to the code folder's path. Now compile the app.py file using the command python space app.py. I'm typing python space app.py and hit the enter button. So this command will execute the Python script and perform a runtime check for any syntax errors or logical issues. After running the app.py file, the Flask framework will host the application locally at the default address, localhost, and port unless configured differently. Now copy the local link provided by the framework. I'm copying it and paste it into any web browser. I usually prefer Chrome. After pasting it, hit the enter button. So the home page of the project has been displayed in the browser. This is the front end built using Flask framework. So here we can see a sign up link, click on it. If we are new users, we have to register ourselves first. Fill in all these details and click on register button to sign up. And if we already have an account, we can directly log in by clicking on this link. So as I'm already a member, I'm clicking on this link. Here we have to give our credentials, username and password. I'm giving mine and click on login button. So it has redirected us to the classification page. So now we have to upload any fruit or vegetable image here, and the application will classify whether the fruit or vegetable is fresh or stale. Click on choose file button. So from sample folder, so these are different classes I have. We'll select any fresh apple image first. So these are the test cases I have of fresh apple. So I'm selecting this one. Click on open. The image has been loaded. Now click on upload button. So we can see this is the uploaded image, and here we can see the classification, that is, it is fresh apple. So the application has correctly classified it as fresh apple. We will try again, click on try again link. We'll try uploading another image, click on choose file button. This time we'll upload this image, click on open. The image has been loaded, click on upload button. This is the uploaded image, and here we can see the classification, that is, it is fresh apple. Click on try again, click on choose file. This time we'll try uploading stale apple image. These are the stale apple test cases I have. I'm uploading this image, click on open. The image has been loaded. Now click on upload button. So this is the image we have uploaded, and here we can see the classification, that is, it is stale apple. The application has correctly classified this apple as stale apple. Click on try again. Click on choose file. So this time we'll upload any fresh banana image. I'm uploading this image. This is the uploaded image, and here we can see the classification, that it is fresh banana. Click on try again. Click on choose file. Now we'll try uploading stale banana. I'm uploading this one. The image has been loaded. Click on upload button. So this is the image I have uploaded, and here we can see the prediction, that is, it is stale banana. Click on try again. Click on choose file. We'll try with this image. Click on open. The image has been loaded. Click on upload button. So this is the image which I have uploaded, and here we can see the classification, that is, it is stale banana. This time we'll try with fresh bitter gourd. So these are the test cases I have. I'm uploading this one. So this is the uploaded image, and here we can see it is fresh bitter gourd. We'll try with stale bitter gourd. Click on choose file. So I'm uploading this image. This is the uploaded image of stale bitter gourd. And here we can see the correct classification, that is, it is stale bitter gourd. We'll try with this one. So we can see the classifications, the correct classifications. This time we'll try with fresh tomato. So I'm uploading this image. The image has been loaded. Click on upload button. This is the uploaded image, and here we can see the classification, that is, it is fresh tomato. Click on try again. Click on choose file. We'll try with this one. We can see it is a fresh tomato. We'll try uploading stale tomato. So I'm uploading this image. The image has been loaded. Now click on upload button. This is the image I have uploaded, and here we can see the classification, that is, it is stale tomato. Click on try again. Click on choose file. I'll try with this one. Image has been loaded. Click on upload. This is the uploaded image, and here we can see it is a stale tomato. We'll try with some more cases. Click on choose file button. This time we'll try with capsicum. First we'll upload fresh capsicum images. So I'll upload this image. This is the uploaded image and here we can see it is fresh capsicum. Click on try again. This time we'll upload stale capsicum image. I'll upload this one. Image has been loaded. Click on upload. So this is the image I have uploaded. And here we can see the classification, that is, it is stale capsicum. Similarly, we can upload any image from the test cases and can get the classifications. Click on choose file, select the image. We'll try with orange this time, one last time. So I have uploaded the image. This is the uploaded image and here we can see the classification, that is, it is fresh orange. Click on try again. We'll upload stale orange image. I'm uploading this one. Image has been loaded. Click on upload button. This is the uploaded image and here we can see the classification, that is, it is stale orange. So now we'll look at the graphs plotted. Click on graph link here. So here we can view all the visualizations made. So this is loss and accuracy curve of hybrid model. I'm zooming it. So in this graph on x-axis, I have epochs and on y-axis, I have for this graph, on y-axis, I have loss and for this graph, I have accuracy on the y-axis. So we can see for every increasing epoch, loss is decreasing and for every increasing epoch, accuracy is increasing. This means the hybrid model is doing well. And this is accuracy scores comparison graph, a horizontal bar graph. In this graph on x-axis, I have accuracy scores and on y-axis, I have algorithm names. Accuracy is a measure of how well a model correctly predicts outcomes. It represents the proportion of correctly classified instances among all instances evaluated. This is precision scores comparison graph. So in this graph, on x-axis, I have precision scores and on y-axis, I have algorithm names. Precision is a measure of the correctness of positive predictions made by a classifier. Similarly, this is recall scores comparison graph. So recall is a measure of the classifier's ability to correctly identify all relevant instances from a dataset. And this is F1 scores comparison graph. F1 scores combine precision and recall into a single metric. It provides a balance between precision and recall, taking into account both false positives and false negatives. So from all these graphs, we can see that hybrid model has outperformed all other models in all the performance metrics. Now click on sign out. So we have developed a robust classification system using machine learning and deep learning techniques to differentiate between fresh and stale fruits and vegetables. By leveraging image processing, data augmentation, and various classification models with hybrid model deployed into Flask, we achieved accurate and efficient quality assessment. So this technology benefits farmers, industries, retailers, and consumers, ensuring product quality, reducing waste, and enhancing overall satisfaction in the supply chain.
Thank you for watching video. For more projects, please visit our website www.trueprojects.in. For updates on latest project videos, please visit True Projects YouTube channel and subscribe.